Hi, I'm Andy Parkin, Managing Director of the multi-award winning Screed. Thank you very much for your question, Daren. And that question is, what is the drying times calculation for a 50mm Supaflo Screed in an unheated internal space using winter temperatures and relative humidity? So I think just starting, I'm going to assume that you've got the sort of classic version of Supaflo and not the Rapide. The Rapide is the faster drying Screed. These type of Screeds drying times will generally depend on the thickness as well of the Screed, so that's something that you've basically got to factor in. But you do hit the nail on the head when you talk about winter temperatures. Certainly in winter it doesn't slow the reactions down, so that's fine. I mean, you don't want it freezing because it's got water in, but it's slowing the reactions down in cement, but not in the calcium sulfate Screed. So that's fine. It's an exothermic product, so it's great for when it's cooler for losing heat for the reaction. And it's a crystallization process. Now, the thing that you're trying to do is you're trying to obviously dry it. And in winter that can be challenging because the moisture needs to come out of the Screed, as opposed to a cementitious product where some of that water is being used by the hydration process and gets used up in that chemical reaction, as opposed to actually coming out of the Screed. So how long? Now, working on that it's the classic version, or should I say not the Rapide version, you're looking at, in the laboratory, so this is what it's based at, in the laboratory at 20 degrees, 60% relative humidity, you're looking at 1 mil a day up to 40 mil and 2 days a mil after 40 mil. So a 50 mil Screed at those or in those conditions would take 60 days to dry. Now, obviously, we don't have that. Humidity's a lot greater, temperatures are low, so drying times are extended. Now, to actually calculate this exactly, you need to know all the factors. So you need to know exactly, the content of water that was in the Screed originally, because that can vary. So depending on the actual flow of the Screed, so if it was at the top end of the flow, that's going to take longer than if it was at the bottom end. So factors like that are obviously in this case are a bit of an unknown. What is the humidity? What is the actual temperature? Is there any moisture being reintroduced? So if you've got people coming onto the site, they've been outside, they're getting their feet wet, reintroduction of water. So there's an old saying, the Screed won't start getting dry, won't get dry until it stops getting wet. So there's some kind of unknown factors in there. So in those sort of laboratory conditions, a 50 mil Screed would take 60 days. So it is going to be prolonged. Now, what you can do with this Screed is you can force dry it. So you can use, if it's got underfloor heating in, you can turn the underfloor heating on after 7 days. Obviously commission it according to the British standard. You don't want any shock within the Screed, which could cause cracking, etc. within there. So commission the underfloor heating, pump the heat through. I'm assuming that that's possibly not an option with it being an unheated building. The other things that you can do is introduce heat into the environment. Now, what you don't want to do is use fossil fuels, because fossil fuels actually add moisture back into the atmosphere. And you're trying to get rid of the moisture out of the atmosphere, obviously out of the Screed into the atmosphere and then out of the building. So at these times it is a bit of a challenge. So I would say you probably need to try to be introducing some dry heat into that building to help it to dry. Now, if it's a real problem and you need to be getting your floor coverings down, etc., time's ticking and time's obviously money for you, there are other options. You can force dry it with blankets. So there are systems to actually blow air around the surface of the screed with these blankets and then draw in the moisture. So literally, I mean, typically with that, you would never start to force dry until after a week. After a week, the product itself is then inert. So after the week, you can start to force dry. With this blanketed system, you're looking at about 7 further days to dry the whole screed. So that could be an option. It's not necessarily a cheap option, but I guess it's all relative to, commercially how quickly you need to get it. You need to get the screed dried. Now, if you're obviously you can never tell whether it's dried until you get the moisture reading. So the British standard is the hygrometer. So with the humidity sleeves onto the surface of the screed, left overnight, reaches an equilibrium, and then obviously the test is made then, looking for 75 RH with the product. The other methods are you could use the carbide bomb test. So you could take a sample, put it in the reader, and that will give percentage moisture, which is 0.5 mil for resilience you're looking for, and 1 mil for ceramics and carpets, etc. So you're looking for one on there. Now, you could use an encounter meter to give you an indicative test. One other indicative test is to actually just cut some polythene. So you can get some clear polythene, 500 mil by 500 mil, tape it to the floor. I would probably select the area that is most likely still to be damp. So the least ventilated, coldest area that you've got on the project, and tape this down. And then if it's still sweating, you're nowhere near. If it's actually stopped, you know that there's a possibility it might be okay, and then you would look to proceed with a moisture test. So I think without all the relative information, and you're not going to have all that information, it's difficult to actually predict in these kind of conditions. I would say at current conditions at -2 outside, probably 5 degrees in a building with very high humidity, I think you could be looking at anywhere up to doubling the normal drying times at 20 degrees and 60% relative humidity. But this is something that is obviously just a finger in the air kind of exercise. So I think you just